Good day everyone, I am Babes Kenson and I'm here today for another video presentation. The objective for today's discussion is to apply definite integrals in solving work problems and also finding the length of an arc of a plane curve. So let's start with applying the integrals in solving work problem. Here is an example. How much work is required to lift a 300-pound crate up a distance of 200 feet using a rope that weighs 4 pounds per foot? So there's two parts here. The first part is we need to lift up the crate. So how much work is required to lift up a box or a crate? The work is required simply 4 times the distance, and so the force is weight of the crate, which is 300 pounds, and we're lifting it up by a distance of 200 feet. So it's going to be 300 times 200, and that is 60,000 pounds times feet. So that's the work required just to lift the crate. Now, we need to calculate the work required to lift up the rope by a distance of 200 feet. So, first we need to write an equation for the force that required to lift up the rope in terms of x. And it's going to be the weight density in pounds per feet times the distance that we're lifting it up. So, the force equation, it's going to be 4 pounds per feet times x, or simply 4x. So the work required is going to be the definite integral from a to b. So from 0 to 200, we're going to integrate 4x dx. So the antiderivative of 4x is 4x squared over 2. Evaluated from 0 to 200, so 4 divided by 2 is 2. So we have 2x squared, and so that's going to be 2 times 200 squared minus 0 squared. 200 squared is 40,000. If we multiply that by 2, that's going to give us 80,000 pounds times feet. So the total work required to lift up the crate along with the rope is going to be the sum of these two numbers. And so 60,000 plus 80,000 is 140,000. You just need to calculate the work required for each item separately and then just add it up. So that's the total work required to lift up the crate and the rope. Now let's move on in finding the length of arc of a plane curve. Here's an example. Let's say that f of x is 1 plus 6 times x raised to the 3 over 2 power, and we want to find the length of the arc from 0 to 1. So you can also write it like this. The first thing that I would do is to find the first derivative. So let's find f prime of x. The first derivative of 1, which is a constant, is 0, and to differentiate this, let's use the power rule. Let's rewrite the constant in front of it, which is 6. Take the exponent, move it to the front. So we're gonna multiply 6 by 3 over 2 and then subtract the exponent by 1. 6 times 3, that's 18. 18 divided by 2 is 9. 3 over 2 minus 1, that's 3 over 2 minus 2 over 2, and that's 1/2. So the first derivative is equal to 9x to the half, which is the same as 9 square root of x. So now, what we are going to do is we're going to square the first derivative. 9 squared is 81. The square root of x times the square root of x is simply x. So now let's use the formula. So in this problem, we can see that a is equal to 0, b is 1. And let's replace f prime of x squared with 81x. So this is 1 plus 81x dx. Now let's use u substitution. Let's make u equal to what's on the inside of the square root, 1 plus 81x. Therefore, du is going to be 81 dx. And if we solve for dx, it's du divided by 81. Now we need to change our a and b values using this formula. So if we plug in 0, this is going to be 1 plus 81 times 0, which is just 1. And if we plug in, that's 1 plus 81 times 1, which is 82. So those are the new limits of the integration. And then this is going to be the square root of u, then replace dx with du divided by 81. So now let's move to the constant to the front, that is the 81. So we're gonna have 1 over 81 integration from 1 to 82. And then square root of u is basically u to the 1/2. Now let's integrate it. If we add 1 to the 1/2, that's gonna be 3 over 2. Now instead of dividing by 3 over 2, we're gonna multiply by 2 over 3, and then we have a 1 over 81 in front. So 1 times 2 is 2, 3 times 81, that's 243. And let's plug in 82. First, we're gonna have 82 to the 3/2, and then we'll plug in 1 minus 1 to the 3/2, that's 82 to the 3/2. Final answer is 2 over 243, and we can make this as 82 times square root of 82. And 1 raised to the anything is just 1. Now, if you want to convert this answer into its decimal equivalent, and if you do that, it's going to be about 6.103 approximately. So that's the answer for this problem.